So far, we have seen how to calculate measures of location for discrete data points or for a set of data given in a frequency table. However, in this video, we're going to look at the calculation of measures of location for group data. And usually group data is the data that is difficult to present as individual data points. For example, consider the time to finish a race in minutes. It will be pointless to record the exact time when everyone arrived. And in any case, it will be very difficult to record the exact time because time is a continuous variable and you wouldn't be able to find the exact time, let's say 3 minutes, 1.3572 seconds. You don't have the appropriate measuring device to do that anyway. So in this case, we create classes or intervals of time and we record the number of people that arrive within that interval of time. So here we have the time to finish the race, and let's say the first interval is from 10 inclusive to 20 exclusive. That means that in the first 10 minutes after the beginning of the race, 12 people have arrived. Then in the following 10 minutes, 20 people arrived, and so on. So obviously, those are the real top athletes. They are few compared to the rest of the data set. And those are the people who joined in the race for fun. They probably took a leisurely walk along the race, so they took about an hour. And as you would expect, in most variables, the bulk of the data is collected here in the middle. The extremes are usually rare. So let's see how we can think about this data set first of all. How many people did participate in the race? So to answer this question, n is the sum of the frequencies. And if we add the 12, 20, 45, 19, and 4, we get 100. So 100 people took part in this race. The minimum time to finish the race is probably 10. And the maximum time is 60 minutes. Now it's important to note that we really don't know how those 12 people arrived within the interval. This was mentioned before when we talked about cumulative data. So let's consider how we estimate the mean. And I need you to stress the point that we are going to calculate an estimate of the mean for reasons that will become apparent soon. So this is our cumulative. This is our group's frequency table, and we want to calculate the mean. Now, since we don't know how those 12 people arrived within the interval, we are obliged to make an assumption. Our assumption is that those 12 people actually arrived in the middle of the interval. So we assume that those 12 people did not take a 10 to 20 minutes, that they all took 15 minutes, which is 10 plus 20 over 2, which is the mid-interval value. We also assume that those 20 people arrived at t equals 25. So by doing that, we have actually converted the grouped frequency table into a simple frequency table. And in this case, we calculate the mean in exactly the same way as we calculated the mean for a frequency table, namely by saying that x bar, which is the mean time, or t bar, whatever you want, is equal to 15 times 12 plus 25 times 20 plus 35 times 45. And finally, and this is all divided by the sum of the frequencies, which we calculated earlier as 100. And this gives me 33 0.3 minutes. Now, since this is an estimate of the mean, because we really are making an assumption about this 15, it is much better to say that the mean is approximately equal to rather than equal to. Now, someone might say that those 15 people may have actually arrived evenly distributed in the interval. And in that case, their mean time would be the same as the 15. So it makes no difference. Now let's look at the mode. In the case of the mode, we simply look at the highest frequency. So the 45 is obviously the highest frequency. So what we say is that it's not a mode, it's a modal class, which is the 30 to the 40. And this is the interval of time during which most people did arrive at the end of the race. Now let's look at the median. And this is something that we did in the previous video. In this case, this is our time to finish the race. This is our grouped frequency table. And we convert it to a cumulative frequency table in exactly the same way as we did in the previous video. And then if we draw the cumulative frequency curve, we can tell from the graph that the number of participants was 100, because this is the maximum point where the curve reaches, and that the minimum time taken to finish the race was 10 minutes, and that the longest was 60 minutes. And we have seen how to extract the median from this kind of curve. We simply divide n by 2, we get 50, and then we move across. And then we reach the curve, and then we go down. So the median is 34 minutes. That tells me that as many people arrived in less than 34 minutes as people that arrived up in more than 34 minutes. So this is the way to calculate the median. Now the next part of the video is beyond the measures of location, the traditional measures of location. Let's look at something that is called percentiles. And let's take our same curve. Now there are 100 participants. Now if we say that something is the 20th percentile, that means that it is a data point below which 20% of the data lie. So 20% of the cumulative frequency is 20. So this person here, who is number 20, arrived at a certain moment in time, which is, say, it looks like 25.5. At this moment of time, 20% of the people had already arrived. So the 20th percentile is a value below which 20% of the data lie. So this is the 20th percentile. We can look at the 90th percentile. It's obvious if we go down that it's 45 minutes. So the 90th percentile is 45 minutes, and that means that 90% of the people arrived in less than 45 minutes. Now, we always begin the percentiles from the bottom up, whether that's good or bad. In this case, it's the time to finish a race, so it's good to be at the 20th percentile because you're in the top 20%. But if those are exam grades, then it's not so good to be in the 20th percentile because you'll only be better than 20% of the class and 80% will be doing better. So percentiles are also a good way to understand the data.